Hello everybody, my name is Valérie Muset, I work in CEREMA, and I will now present a part of the results of Surface project concerning database and the impact of road lighting. I will first begin with presenting the actual practices on road photometry, then the database as a test set, and the impact of road photometry. First, I will describe actual practices and contexts and the history of CIE standards. In fact, we have different systems of tables, air tables, and Nordic tables and sea tables. But all these tables were defined with boundaries and specularity. And for each of these tables, you have classes depending on specularity, and also you have typical values. And in this graphic, you can see the boundaries with the S1 axis and also the typical values. So you have here the same data with another representation. And the air table were developed in the 70s by Philips. The N table were developed for Nordic countries with a database of nearly 300 tables. And the same database was used later by Berghout to propose two standard tables, C1 and C2. So here you have a representation of this typical data with Q0, the lightness factor on the x-axis, and S1 on the y-axis. And you can see all this system of all the typical values of the RCN system. And we made a survey during Surface project, but also during CIE TC 450 meeting in Washington, and of which table do people use among Europe and among the world. And you have here what is the result we got, and we can see that Nordic countries use the Nordic table and the wet tables. But if we consider all countries, the most used table are R3 and C2. And you can see here that in fact, these two tables are really close. I mean, there's the same Q0 and only a small difference between S1. And we have also learned that usually people don't make measurements and they use these typical tables. Sometimes they change Q0, but really they don't use the complete air table. However, several studies have shown that these tables are no more representative of actual pavements. So this is why during our Surface project, we did a call for air table data. And we need new tables. We need tables representative of actual practices for Surface project, but for the community, for TC 450, which is the group focused on road photometry. So we did several calls for data in Korea, in Berlin, in Washington, and I will now present the data we have. So in fact, we first decide to focus on laboratory gonio retroreflectometer. So this is why I will not speak of portable devices here. This is why we don't took into account Nordic measurements, because they were done with portable device. To begin, we use data from laboratory gonio-reflectometer. And this is the tables we have. 40 tables from Switzerland, 182 tables from France, and 18 Q0 on S factor from Finland. We decided to make a distinction between stabilized pavements and new pavements. So I will first present the results with this distinction. So what you can see here, so we have Q01 here, and S1 here. And in green, you have the old database of the 70s. In red, we have our surface database with new pavements. And in orange, we have a database of what we called stabilized pavement. I mean, it's pavement extracted after 2 years of circulations or more. And what we can see here is that we observe a very important age and initial treatment effect. I will go in more details now. Yes, you can see here a lot of specularity for new pavements, what we don't measure for age pavements. And this age and initial treatment effect is well known. It was already shown in a LCPC study. Here there was a very thin, in red, you can see a very thin asphalt concrete. When it is brand new, the specularity is very high, and this specularity really decrease very quickly with time, and then you have a kind of stabilization. The figure you see are the age in month of the pavement. In another study, you have here in blue a classic very thin asphalt concrete, and again, and the hour we present the effect of time, and you also see an important decrease of specularity with time. For those two pavements were really raw pavement, and you see this decrease. But with treated pavements, which are in this study in light blue and orange, these pavements were initially treated, and you see that the initial specularity is not so important, and that the pavement becomes lighter with the effect of time on traffic. I now share another study from a French group called Pavement and Lighting. And in this group, we did measurements of several brand new pavements and classic raw bituminous pavement with high specularity. You can see them in red, but initially treated pavements are really less specular. We also measured different concrete, dark cement concrete and light cement concrete, bituminous asphalt, and also dark cement paving. The aim of this study is to measure new urban pavements. And we did measurements of pavements that were, to my knowledge, not measured before. And we have quite interesting results on cement concrete and cement paving with very light characteristics. But we can see that brand new asphalt pavements are really very specular also. So I go back to the database we use in surface projects. So we compare, in this picture, you can we compare the old data, again in green, to our database of stabilized pavements. And our data collection contains a majority of bituminous concrete, but also some pavements with synthetic binders and cement concrete. And you can see that we have lower Q0 than the old database. However, our aim in Surface Project was to propose new air table, to propose new typical pavements, to have a big database. But the question we have is that we only have data. The problem is that we have only data from Switzerland and France and small amount of data of Nordic country, but we have no data from the south of France. From the south of Europe. And the question is, are we really representative of European pavements? So we don't know, and we prefer not to give any, we will not present other typical stable and so on. So what we decided was to make an analysis with a choice of specific behavior on pavements. We decide to select a test set with a bituminous medium of our database, a specular pavement, a very bright pavement, a very dark, and a bituminous diffuse. And here you have a representation of the reflection indicatrix of our 5 selected pavements, so a medium air and more extreme pavement compared to the reference C2. And we then study the impact of these different pavements on road lighting design. So our approach is the following. We did Dialux standard calculation for lighting installation. It's a 2-lane installation. We choose the lighting class M3. It's a single side installation. And we optimize the lighting with the reference C2 pavement, which is the classic method to our knowledge among Europe and among the world. People don't make measurements, so they use a reference pavement. Sometimes it's R3, C2 or something else, but they have the same approach. For our study, we choose the reference C2 as for our lighting design. So here you have the result of the calculation, and you can see that we fulfill the normative requirements for the M3 class. And then we say, okay, this is the reference calculation, but in reality, there is another pavement on the road. So let's see what is the impact of using the photometry of this pavement to the calculation. So here you have the reference just to remind, and then we use all our data sets. And you can see here that for the very bright pavement, you have good uniformity, but we really overlight the road. We have 2 candela per meter square instead of 1. And for the other pavement, we don't comply with the standard. We have problems of uniformities, sometimes glare problems, and also luminance problem. So we don't comply with the standard. If we make a design with a reference pavement and in reality there is another pavement, and this is probably, this occurs every day because everyone take a reference pavement and in reality there is another pavement. So I think it's probably very rare that the requirement is complied. So then we said, okay, let's think that the people know the photometry of their pavement and take it into account to optimize its installation. So you can see here the result of the lighting design, taking into account the real characteristic of the different pavements. So we have difference, of course, in luminaire power, pole distance, and well, on every geometric factors also. And then hopefully we are able to comply with the standard requirement, as you can see here in this table. Then you have here the power density indicator and annual energy consumption. So we look on the impact of the pavement photometry for power density and energy consumption. And you can see that, of course, for the very bright pavements, we save energy. But for the very dark one, more light is needed, and the percentage is very high. So to conclude, I think we all know it, but it was important to prove it again and to see what can we done. So what can we do? But in practice, we use the reference CIE tables, but this leads to errors. The standard is not respected in the majority of the cases, so it could give visibility problems and safety problems. And in some cases, we have too much light or too little light. The quality of the light is generally not good, and it could give also energetic waste. So there is, however, we still use reference CIE tables. And I think we must go to something else, because there is a new context. Nowadays, there are new types of pavements. I have shown the pavement we find in France in urban areas. So we have really a huge diversity of pavements. And there was also nowadays new light sources and possibility to adapt the light. So we must go further and find new practices. So there is a need to have a new database and to make more measurements. So our database in Surface is a first step. We choose a test set, but we are not really happy with this because it's not enough. We really represent only center of Europe, and this is not enough. And we really need more data. I mean, up to now, we choose to take data only from laboratory device, but we need data from on-site device. We did this choice to focus on laboratory device because we have no idea of the uncertainty of lab and more in. And we have no idea of uncertainty of on-site devices. So we are working on this subject on Surface project, and we hope we will be able to share some results to you. So the next steps, I mean, we will address some of these questions during a Surface project, especially we will propose you some guidelines of measurements. We will propose a methodology to evaluate uncertainty. And as Joanna said, we did some round-robin tests during our project. So we will have no knowledge about the uncertainty of lab and on-site devices. And so the next steps are during Surface project, but Surface projects finish in the end of this year. And so the next steps will be really during CEI TC 450 of the CIE. And we only need your help to go on working on this subjects. I thank you very much for your attention, and do you have any questions?
Again, as far as there are, Stefan asked a writer on our chat for a question. So I leave the screen to Stefan.
We don't hear you, Stefan.
Yes, now you can hear me?
Yeah, perfect.
Yeah, fine. Thank you for the presentation. I have only one short question. You mentioned dialogue.